Hello and welcome everyone to OnPoint Technologies and PCM webinar Thursday. We are thrilled to have you with us for Cisco webinar, which is Security Beyond the Firewall. And to present on this topic, we have got Marc, who is Channel Systems Engineer from Cisco Cloud Security, and also Daniel Bates, who is Systems Engineer from Cisco Cloud Security as well. Before going into our main presentation, we have got a few housekeeping items. Please remember to enter your question in the question box on your right-hand side, and I'll read those over to our speaker at the end of the presentation today. We do send out a survey at the end of the presentation. Please fill it out and let us know how we did, as well as topic you'd like to see covered in the future. You should see the survey in your inboxes later today. We are also recording this session, which will be available to playback in the next few days. Recordings are posted to our webinar page, which is www.onpoint.com/webinars. You can also find upcoming webinar schedules over there as well. And with that, we are going to go ahead into our presentation. I'm happy to hand it off to our main speakers, Daniel Bates, System Engineer, and also Marc Dorn, who is CSE, Cisco Cloud Security. Daniel, I'm giving you the ball now.
Thanks, Newman. Hello, everyone. Welcome to this webinar. So my name is Daniel Bates, and I am a security systems engineer with Cisco. I'm joined today by Marc Dorn, who's also a security systems engineer. And we're here today to talk to you about Cisco's solution for security beyond the firewall. Now, let's take an example of a difficult security threat that we are dealing with today. A difficult threat that requires us to go beyond just the firewall to effectively address. I want to talk today about ransomware. So what is ransomware? Well, ransomware is a particularly nasty and growing trend within the landscape of cyber threats. Rather than stealing data, attackers are using malware to encrypt critical files within your network, essentially changing the locks on your own system and crippling operations. And attackers will withhold access to critical information and make extortion demands of companies in exchange for releasing that data. Now, ransomware is not a new problem. We first saw an example of this type of attack about 27 years ago with PC Cyborg. But it wasn't really a common problem until late in 2013. And it really took off in 2014 with CryptoWall and then Tesla Crypt and hundreds of other variants that have really just exploded in popularity. So ransomware is popular, and it's popular because it works. It's simple, it's easy to use, and it's ridiculously lucrative for cyber criminals. A single ransomware campaign can generate $60 million from companies and consumers, and it's estimated that over 9,000 users are paying ransoms per month. Ransomware attacks are actually the fastest growing attack type according to a recent Verizon report. Well, what can we do about it? Well, we have a number of really good solutions here. We have something that we call the Cisco Ransomware Defense Solution. And we're going to talk about that today. And this is what really goes beyond just having a firewall, right? Just having that perimeter defense and having security on your endpoint. Now, I want to point out this is not a silver bullet. It's not a guarantee, because we all know that there's no detection or prevention method that can ever block 100% of advanced malware all the time. It's just not realistic, but our solution is extremely effective. Now, the Cisco Ransomware Defense Solution is comprised primarily of AMP, or Advanced Malware Protection, and Cisco Umbrella. Those are the products that we're going to talk about today. And what we do is we'll try to prevent ransomware from getting into that network whenever possible. We're going to stop it before it can gain that command and control communication. We'll detect it if it's present within the network. We're going to contain it, and then we can perform incident response to address those vulnerabilities and to remediate those problems. So let's talk about a typical ransomware infection. How does ransomware work? Well, most ransomware happens in 4 stages. So first, the ransomware is deployed using an infection vector. Now, this is often through an email attachment, a hyperlink, or a malicious website. Second, the ransomware is going to call back to its controlling infrastructure and generate an encryption key. Now, this encryption key is used to lock up critical files. And then finally, the ransomware will display a message, and the attacker is going to wait to receive that ransom. This is the typical path that a ransomware infection is going to take. Now, most ransomware that we've seen in the industry today relies on those command and control callbacks. And you can see here a comparison of some of the top variants as of March last year. Locky, of course, is very common. It uses the DNS callback. It can also use an IP callback. SamSam does not use any kind of callback at all. It has hard-coded encryption keys, but it's really unique among ransomware because that's not very commonly seen. Most types of ransomware are going to rely on these command and control callbacks, and we can identify that using DNS and using IP layer protection. All right, so here is how we prevent and contain ransomware using Umbrella and AMP. All right, so you can see here that the two threat vectors, compromised sites and phishing, they're both going to result in a lot of web redirects or web links that are going to land the victim on an exploit kit domain. And that's going to serve up that exploit kit, such as Angler, Nuclear, Rig, and there's some others. And we have the capabilities to detect that using Umbrella and block that communication. We can also block the communication between the exploit kit and the malicious infrastructure that will try to drop that download onto the endpoint. But if all of that succeeds, AMP for endpoints is going to be there to recognize that file and block that file as it tries to establish presence on the endpoint. We can also block attachments if they're being delivered directly. And then finally, as the ransomware tries to generate that encryption key and submit it back to the attacker's infrastructure using that command and control callback, Umbrella will be able to recognize that and block that at that point. But so I want to turn this over to Marc to talk more in depth about Cisco Umbrella and how it works. So Marc, I'm going to make you the presenter right now.
Thank you, Daniel, for that explanation of ransomware. It really is a big threat, and we must take it seriously. And one area that is interesting that I like to point out, and one reason for this webinar, is that we need to look at security in a different fashion moving forward, right? Because ransomware, quite frankly, it is very prevalent. And even though we have lots of security in a stack that's protecting our environments, it's still making it through. So where Umbrella really fits well is that we are looking at this threat and other threats from a different perspective. And where we want to do all of our visibility, control, and protection is out beyond the firewall. We do this at the DNS layer. And because of this, we are able to block connections to malicious destinations before an IP connection is ever made. It's very elegant. It's very easy to implement. As a matter of fact, it'll be the easiest security solution you ever implement in your life. And it will add no complexity and no latency for your users. And quite frankly, it's going to be invisible to all of your users as well. The other important thing to note is because we're doing this at the DNS layer, we don't care how these command and control callbacks are happening. We're able to protect over any port and protocol. So why is it important, and why did Cisco decide to do protection at the DNS layer? And it's really because of what we learned from previous cyber attacks. The current security stack is very reactive, right? We wait for patient 0 to be attacked, then we analyze the attack, we see how widespread and prevalent it is, then defense signatures are built, those are pushed out to security solutions, and yay, we are now protected. Cisco Umbrella, however, has taken a different approach. Because we are at the DNS layer, and we know that malware, and specifically ransomware, doesn't just happen today. These new attacks depend on quite extensive infrastructure to be built before attacks are launched. So reconnaissance is done by the bad actors. They need to spin up new domains. They need to assign IP addresses to those. They need to build servers. They need to do a pilot program, right? This malware, ransomware, is malware with a business plan. So they're going to test that out before they launch that attack. And because we're at the DNS layer, we actually can see all of that infrastructure being built before those attacks are launched. So how do we do that? Well, quite frankly, it is because we have a ton of data. We are a free recursive DNS provider. We are providing recursive DNS for over 85 million users. Those are global users, many of which are home users. So we actually are able to analyze DNS requests from infected hosts as well. What this equates to is we're seeing 100 billion DNS requests every single day. The only other recursive DNS provider that sees more than us is Google, and they see about twice as much as we do. However, what we do with that data is very important. We have an army of engineers who are building statistical models to analyze this DNS data, this threat data, indicators of compromise, in real time to provide real protection for all of our users, and we are doing that as a first layer of defense. So we're not here to replace anything in your security stack. We're here to make your security stack work better. But what's really cool is because we are seeing over 2 million live events every second, we combine that with 11 billion historical interesting indicators of compromise, and we can see what a domain is, how it's being processed, who registered that domain, is it a domain that looks like a common name that could be used in a spear phishing attack, etc. We are doing all of that in real time. Okay, so we don't build signatures, we just provide real-time security for current events that are happening on the internet. Now, what does that mean? Well, we see 3 million new domains every single day. We are able to take all of the domains that we know about, and that's pretty much everything, and we can identify over 60,000 new malicious domains every single day, and then enforce protections from people trying to go to those destinations over 7 million times. We also offer content filtering, so this doesn't include content filtering blocks that we can provide. However, we're doing all of this enforcement, we're giving you visibility and protections, but we're also doing what we just do better than everybody else, which is we just change a name to a number. That recursive DNS service that we provide, just to do that for our customers, we do faster than anybody else in North America. And we are highly rated as far as recursive DNS response times throughout the rest of the planet. So I'm going to jump into a demo real quick here to show you just how easy this is to deploy and what kind of information you can gather. So we are software as a service. You will not be shipped a box if you want to utilize the protections that we can offer you with Cisco Umbrella. You log into a portal just like you would Facebook, and you can start to get visibility into what's happening on your network and what your users are doing. From a configuration standpoint, there we go, setting us up is very easy. After you get your onboarding email, you will come into your dashboard, you will go into identities and networks, and you will spin up a new network. It's very simple. All we need to know, you need to define that network so it makes sense to you. What we need to tie your account to policies is to know what IP address we're going to see the next DNS request originate from. We do support static IP addressing and dynamic, so there's no customer that we can't support. If you want a daily digest of how we helped protect your network over the last 24 hours, it's very simple. Give us an email address and we will package up everything we found that was bad and email that to you on a daily basis. You save that, then all you need to do internally is change the forwarders on your DNS servers to point to our resolvers, which are 20867222222, and we will start providing protections. Pretty simple. But you have remote users, right? Roaming computers that are outside of your network who are not opening up a VPN and VPNing back into your infrastructure for additional security. So we need to extend that visibility, control, and protection out to those remote users. Very simple. Download either one of our very lightweight enterprise roaming clients for Windows or for Mac, and deploy that as part of your image or whatever you're using for a software deployment platform. Your users will be instantly protected. Now again, they're getting this protection when they're on the network, right, or off the network, with a VPN or without a VPN. They're going to get this first layer of protection that they don't have today all the time. You, as the administrator, will have visibility into everything that they are doing, even when they're not connected to your network. If you are already a Cisco customer and you have deployed AnyConnect as a VPN client in your environment, you have already deployed our version of the agent that is required on those roaming computers. Simply download the profile, upload that to your firewall, and the next time your users connect, they will then get that profile and have that additional protections, as well as giving you additional visibility into what those assets are doing. So what are we going to do? What are we going to show you? That's what's really important, is we can show you all of the security activities that people are doing. We can also show you all of the general activities that people are doing, but security is what we focus in on. So I can see if my environment is getting safer over time or if I have new threats that I need to focus in on. Okay? I can see identities that are top concerns for me, or top domains that people are going to that they probably shouldn't be able to do. I can focus right in that. I can drill into a suspicious destination. I can see how prevalent callouts to this particular domain are in my environment. I can see who is actually making those requests, build a report to start to do remediation, because this is a bad thing, right? We've got something in my environment that is phoning home, and I need to clean that up. But I also need to prioritize my activities. What's nice about Umbrella is that I can see who is phoning home and I can see how often. But what's really nice is I can start to compare that with my global community, right? We're seeing 100 billion DNS requests a day. Just want to really reemphasize that. If I see a high percentage of requests going to a malicious domain from my environment as compared to the global environment, I can assume that that is a targeted attack, and I need to take more corrective action, right? That's got to be more priority for my environment. So that is, in a nutshell, what you can do with Umbrella. What I do want to show you really quickly is some of the threat intelligence that is powering Umbrella and doing this predictive determination whether a domain is good or bad. So because we are able to see every domain at some point in time, we are able to really focus in on who is doing bad things. So Microsoft I just used because they are, that domain can be used in spear phishing attacks very effectively. Right, and what I can also see is that there are already new domains being spun up in the last 30 days that have the word Microsoft in it. This could definitely be used in a spear phishing attack to infect hosts, and lo and behold, there we got proof that we've done that. Now, I did mention initially that we are trying to prevent or detect and determine what a domain is going to be used for prior to an attack being launched. Let me give you an example. This is a domain-generated algorithm domain, so it's a randomly generated domain name that was used in a Locky attack late last year. Okay, and we have one of our statistical models is DGA prediction. So we are backward engineering malware, and we've automated that process. We got pretty smart people in our corporate basement that are doing this backward engineering. And what happened was during this attack, this domain was generated, used in the attack, and at some point, because DGAs are used to make malware very robust and be able to move quickly. This domain was actually registered on July 21st. However, because of our threat intelligence, because of our integration with other security solutions from Cisco, we had actually already tagged that domain, as random as it seems, as a botnet 4 days before it was ever registered. Okay? Now, currently today, we know that this domain has been defanged, if you will. There's no IP address associated with it, but there are still command and control callbacks happening, right? There is still a threat out there. I can assure you that the traffic patterns are changing and that this will likely be used in another attack very soon. And as proof for that, I can show you that this domain was also used in that same attack late last year. It was defanged eventually as well. However, as I do a lot of demos, I did see that the traffic patterns were changing, which I thought was odd one day, and lo and behold, I come down and I do my investigation, and it was reassigned an IP address. So this is likely being used in another attack, and all of our customers, because of the threat intelligence that we provide, are protected automatically for this. So kind of to wrap up, what I really want you to know is that you can add this layer of security that is out beyond your firewall very quickly and easily. We can make very good determinations about what is a safe destination and what is a bad destination, but we also are able to determine things that are gray. They're not quite bad, but we know they're not safe. That's our intelligent proxy, and what we will do in that case, instead of either allowing the traffic or blocking the traffic, we will just redirect that connection through our intelligent proxy for additional inspections. This is where we can do URL inspections, we can do file inspections, we can do comparisons with AMP and Threat Grid to see if files have been seen somewhere else and figured out to be bad. But that is some deeper level of inspection that we are doing. So to really wrap this up, Umbrella is very effective at stopping bad things from getting into your environment to start with. However, if something does get past us and all of your other security stacks or comes into your environment through some other avenue that you don't have protected yet, and there's always a hole in every wall, we are also very effective on those command and control callbacks. So everything is dependent on DNS, right? Even the bad actors are creating malware that is dependent on DNS. So those command and control callbacks are actually, we're very effective in that regard. And quite frankly, those files that get into your environment through some method that you may or may not be aware of, a hole in your security stack, that is where AMP comes into play, right? We have another solution, which we're going to go over right now with Daniel, on what we can do to monitor that file and how it is interacting within your network. So Daniel, what I'm going to do is attempt to make you the presenter and hand it right off.
All right, to talk a little bit more about, that use case where either, the file was dropped through some infrastructure that managed to get past Umbrella, which is very, very rare, but it's going to happen eventually, right, at some point, or more likely, if the attacker is sending a malicious file directly as an email attachment or some other means of putting that file into your environment. So how do we block that? How do we get visibility on this malicious file? Well, the traditional way of dealing with malicious files like that is with something like a point-in-time detection tool. That's what I like to call it. Point-in-time detection is any technology that evaluates a file or some traffic at a single point in time and makes a judgment at that point as to whether that file is good or bad. And if it's a bad file, it's going to block it. And if it's benign or unknown, it's going to let it through. And that's where the analysis really stops. But modern malware is far too sophisticated and too dynamic for us to think that this type of detection technology alone is going to be able to detect all malicious software that's trying to infiltrate our systems. And like I mentioned before, there's no detection method that can ever be 100% effective at detecting all threats that try to infiltrate the system at all. So these advanced malware techniques, right, the sleep techniques, the unknown protocols, and everything else that attackers are using are able to bypass that firewall, that antivirus. And we need to go beyond the firewall and have a solution that gives us visibility into the activity of those files and control over what those files are doing. And that's where we come in with Cisco AMP. So AMP uses three main tools to keep your network secure, and that is threat intelligence and analytics, point-in-time detection, and retrospective security with continuous analysis. So let me unpack these a little bit. Before an attack even occurs, we want to strengthen your defenses and harden your networks using the best threat intelligence and advanced analytics possible. Now, you've seen some of this with Cisco Umbrella already. We have a large amount of threat intel and analytics that we can provide because of our position within the industry and the sheer size of our threat intel organization. I'm going to talk about that on the next slide. But that's really the key feature here is, you know, a security solution is only as good as the intelligence that we can provide to it in order to detect malware, and our intelligence is extremely good. We're monitoring 35% of worldwide email traffic. We're scanning 100 terabytes of data every day, and that helps us come up with about 1.5 million unique malware samples every day. But I'm going to cover this a little bit later. So if someone does launch an attack against your organization, we've got that point-in-time detection. And we've got a lot of tools at our disposal to accomplish this. We've got file reputation. We've got one-to-one signature-based matching. We've got fuzzy fingerprinting. We've got static and dynamic analysis using a sandboxing technology that we call Cisco Threat Grid. This is all built into Cisco AMP as a first line of defense, and this allows you to automatically block as many known and emerging threats as possible before they can even breach your defenses. And this is really good, right? We need to have this, but there's no point-in-time detection method by itself that can ever catch 100% of malware. So while point-in-time detection is essential, we actually need to go beyond that. We need to have more than that. And Cisco AMP goes beyond that by providing continuous analysis of every file that's on your system, whether we think it's good or not. We're going to continue to watch it to see if it has any behavior that might be suspicious. And with retrospective security, we can show you, we can rewind history and show you what happened before an attack. We can show you where that file came from, whether it's tied in with any other files that we've also identified, you know, and roll back that history so that you know where this threat came from and you know how to deal with it effectively. All right, so let's talk a little bit about threat intelligence with Talos. Talos is our research organization. It's the largest threat intel shop in the world right now. And like I said before, it monitors about 35% of worldwide email traffic. That's about 1.5 million malware samples every day. And it's powered by this unrivaled amount of advanced intelligence, so our users can rely on up-to-date protection whenever and wherever they are. Now, Talos is a recognized leader in threat detection. We are constantly being quoted by industry. Our researchers are interviewed and consulted for details on a lot of threat outbreaks. Just this morning, there was a critical vulnerability in Apache that our Talos organization identified and is working actively to block. So these types of stories happen all the time. We have over 280 full-time threat intel researchers and malware analysts that are working around the clock to catch the threats that traditional security infrastructure and traditional analysis just can't deal with. And Talos provides us with that 24/7 view into global traffic activity, which allows us to analyze anomalies, identify network intrusions, and uncover new threats. And we are automatically updating all of our security products with this Talos source intelligence every 3 to 5 minutes, which means that your company's threat protection will always be up to date. So this really helps us, get the answers to the questions that we're going to ask whenever something gets through. What happened? Where did this malware come from? Where has it been on my network? What's it doing right now, and how do I stop it? And to answer these questions, I'm actually going to give you a quick demonstration of AMP for endpoints. So let me bring this up right here. So this is one of our dashboards for AMP for endpoints. This is one of the places that you can go to find out about what's happening when you get alerted that there's some malware or some indication of compromise on your network. All right, I can see some heat maps here. I can see when my attacks were occurring. I can see where they were occurring. I can go here to my inbox, and I can start to work on some of these events, right, begin my workflows. And what I'm going to want to do is I want to find out what happened during this attack, right? I see a number of incidents with some of my systems here. Like, let's look at this one, the zero access. We have a lot of threats that were detected. It looks like there were some vulnerabilities that were exploited in Java and in Flash Player. If I want to find out more about what was happening on this particular machine, I'm going to turn to something we call the device trajectory. And I've got that here for you right now. The device trajectory is what we can use to tell the story of the attack and paint that picture of what happened on this system over time. All right, and right away I can see there was a connection from the Chrome browser to a Google search page, and that search page landed the user on this malicious website. Now, of course, if my user had Umbrella, we would have been able to block this right away. And that's the key benefit there of having Umbrella along with AMP. But let's take this a step further. Let's look at what happened here. So website launched Java using JP2 launcher, which brought up Java 7 Update 10. All right, and that brought up this specific malware threat, this zero access threat. Right here, we identified it as the zero access Trojan, and we were able to deal with it, right? In this case, my policy is set up to not quarantine a file. I want to be able to show you what this file was doing over time. So let's take a look at it. We see the file was created on the system. We see that it was moved into another directory, and then it was executed, and it starts reaching out to different websites, different IPs. Again, Umbrella is going to come in here. It's going to help me understand whether these were malicious IPs or normal command and control, DNS queries, right? So it's talking to this website over port 53, that's DNS, but was that a good site or was that a bad site, right? Umbrella can tell me that. And here I see it reach out to maxmind.com. It's doing some geolocation. It finds out where the nearest Amazon AWS instance is, and it goes ahead and downloads that stage 2 malware. It downloads that dropper. And it's going to download it about 12 times to make sure there's no transcription errors, and it's going to go off and do the things that it wants to do, which in this case is it's going to exploit a vulnerability in Adobe Flash to conduct privilege escalation and to try to get root access on the system and then do all the things that it wants to do there. And so if I want to know more about this file, right, where did this file come from? What's going on with this file? I can click on it here, and I can get a quick context view that tells me this is a malicious file, right? It's present on VirusTotal. That means it's pretty well known. I can click on the file trajectory right here, and I can see a little more information about it, right? Where did it come from? Well, it came from Java 7 Update 10. That's the software that created this actual malicious executable. Here's some information about the file itself. Here's some of the network profile for this particular piece of malware. What IPs was it connecting to? What URLs was it talking to? Where did it come from? What ports was it talking on? I've got all this information here at my disposal. And we noticed here that it came from Java 7 Update 10, right? So that the malware was able to exploit a vulnerability in Java 7 to create this malware. Now, this particular build of Java is really old. It's really outdated. It was actually released in 2012. It's very vulnerable software. And in fact, AMP is keeping track of the software that has vulnerabilities that it's noticing that I'm running on my system. So in this case, Java 7 Update 10 right here, it actually has 99 severe vulnerabilities that are published that are associated with this build. And if I want to, I can click on any one of these CVE numbers and look at the exact vulnerability that was mentioned there. But I don't really need to, right? I know 99 vulnerabilities, that's too many. I need to patch this software, and I'm going to do that. But it's going to take me a minute to find the patch and to roll that out. And in the meantime, I have an open vulnerability here. I need to patch this hole. So what I'm going to do is I'm going to add Java to an application block list. And that's going to prevent Java from launching just until I can update it and patch it and get rid of that problem. All right, so this is really effective, and I showed you an example of how we can use AMP to deal with malware that we immediately identify, as malicious. We detect it, we know what it is, we're going to block it. But what happens in the other case where we are notified that there is some malicious activity on an endpoint, and we want to go back to the beginning and find out where it came from? I've got one more quick story for you. In this case, I was notified, right, by one of my end users that there's some suspicious activity happening on her endpoint. And I can go in there and I can see that, hey, we detected a keylogger, and we detected a text file, and we detected a remote access Trojan client. Well, this is really bad. This is a really bad day for this endpoint, because with a remote access Trojan client, the attacker can establish remote control of this system whenever they want. And with the keylogger, they've captured the user's credentials, so they have that user's login information everywhere. All right, this is not good. I can trace this back, and I can tell you where this came from. So the keylogger was actually created by a Windows operating system utility. This is a part of Microsoft Windows, right? This is a legitimate OS utility here that is creating malware. It's reaching out to malicious IPs, and it's downloading malware. It's doing all kinds of crazy things, right? And I see over here I've got Checkdisk. Checkdisk is also creating malware and doing all kinds of malicious behaviors, right? This is not normal activity for Microsoft Checkdisk. And what's actually happening here is the attacker is using some type of DLL injection or process hollowing to hijack this legitimate OS utility and get it to do bad things. But let me follow this trace back. Right? I can see that Checkdisk was actually executed in this manner by this unknown file, a.exe. Now, what is a.exe? If I follow this line back, I can see that, I don't know what a.exe is. It's unknown. I've never seen this before. It doesn't show up on any signature. No antivirus is going to catch it. No firewall is going to block it. This is a specially crafted piece of malware just for my environment. Well, we can see here that a.exe came actually from Acrobat. That happened right after Acrobat reached out to an unknown IP address, and that happened right after Acrobat opened a PDF. So what really happened here, what I can tell you happened, is this was a spear phishing attack. And the attacker used a malicious PDF that contained some scripting that exploited a vulnerability in Acrobat Reader and got it to download this bootstrapper file, a.exe. And that is what triggered this whole infection. So I can tie the remote access Trojan, the keylogger, and all the other malware that I've seen on this system. I can tie it all back to this one file. And I don't have to wait for Cisco to release a patch for this file. Right? I can add it to a quarantine list, and I can get it off my network immediately. And once I do that, I'm probably going to want to know more about it. Right? So I can submit that file for dynamic analysis into Threat Grid, and it's going to come back with this report that talks about all the different behaviors that we saw that are, that are malicious. Right? So it's got registry persistence. It's got excessive number of spurious DNS queries that are trying to resolve non-existent websites. Right? This is some highly suspicious activity here. It's got an obfuscated portable executable section, so it's either patched or encoded. And I can look at all the network activity. I can look at the processes. I can look at the artifacts, and even down to the level of every registry key that this malware tried to create, modify, and delete. I can see exactly what that behavior was. And this gives me a tremendous amount of information that I can use to identify this malware, to know what it tries to do, what are its characteristics, and then block it everywhere across my network. All right, and that's the power of Cisco AMP. Right? We have AMP available on the endpoint, on firewalls, on mail gateways, and on web proxies, so that whenever we see a file being transferred, we can get this type of analysis, do this deep analytics, and then if it's malware, we're going to block it. All right, so with that, that concludes my demonstration today. And I want to turn this over to answer some questions if any came up during our presentations. So Noman, did we have any questions that came in?
Thank you so much, Mark and Daniel. That was a perfect and great presentation. Yes, we have got a few questions lined up. And the first question is from Paul Tag. In fact, he has asked 3 questions. Okay, I'll ask the first question. The first question from him is, how is Cisco Umbrella licensed? Is it a subscription? Any estimate on costs?
Okay, yep, thank you, and I can answer that. So it is licensed per user, so we don't, from an umbrella standpoint, it doesn't matter how many locations you have, it doesn't matter how many devices each one of your users has, or how many servers or Internet of Things devices, anything plugged into your network. We don't count that. We're looking at employees. If we are in a situation where that is a manufacturing site and you have a lot of non-technology users or users that are not utilizing the Internet, then we can eliminate that from the count. It is a subscription service, so we have 1 and 3 year, I think, subscriptions for that. And as far as pricing goes, I just really honest with everybody that that has 1 decimal point, so I don't really focus in on that. Although your PCM account manager will be able to help you get quotes for our different packages.
Thank you so much, Mark. The next question from him is Cisco Umbrella a replacement for some of the source file functions, such as URS filtering?
The answer to that is we are not a replacement for anything. When we talk about the Cisco security stack and there is overlap, those are items that Cisco is addressing architecturally, right? So we want to have as many protections for everybody in the right places. So just keep in mind that your firepower URL management or filtering, if you will, is still very valuable. But the DNS request can filter out a lot of the noise, right? If we already know the destination's bad, why even make an IP connection or have your firewall do any work? So they work very well together. They will work better together moving forward. No, we are not a replacement, even if you have non-Cisco security in your current posture. We still work with everything in those environments as well.
Thank you so much, Mark. Next question from Paul is there a Cisco Umbrella client for Android and iOS?
Yeah, that's another great question, and the answer is that we do not have a client for Android or iOS. So those are some roadmap items. We understand that there is a challenge there. We are working, our engineering team is working on getting that implementation through our AnyConnect client. But again, that's a roadmap item, so take what I say with a grain of salt. But it is a roadmap item for both of those operating systems. Quite frankly, we just have not seen any major breaches occur because of these devices at this point. And the other thing to keep in mind is that any device, be it Android or iOS, that is on a network, right, wirelessly, that is protected by Umbrella, they would have those protections. But when they are on their 3G or 4G or 5G network, we don't have that. That would be the blind spot in that case. So.
Thank you so much. The next question I have is, can Umbrella protect my roaming computers?
We can. So we do have, we've got AnyConnect integration for Windows and Mac computers, roaming laptops. If you're not using AnyConnect already, there's no problem there. We have a very lightweight roaming client for Windows and Mac machines as well. So it's very lightweight. There's no inspections going on with that client. We're really just redirecting DNS requests no matter what the host receives during a DHCP IP address configuration. So we'll hijack DNS requests, we'll pad that with user information and send that off so we can comply policy and then respond appropriately. The other item in regards to the roaming client is that with that roaming client, we're actually able to do direct to IP connection protections as well. So we will keep 50,000 suspicious IP addresses cached on those endpoints, and if we ever see a direct IP connection to one of those suspicious IP addresses, we will route that traffic directly through our intelligent proxy for additional inspection, so we can block against that as well. So we've got some additional protections you do get with those roaming clients. Great question.
Thank you so much. The next question is, how hard is this to implement in my environment?
It's as easy as changing your forwarders and having an account. So it really, there's no hardware to install for this to protect your entire environment, right? Every device inside your firewall, all you really need to do is change the recursive forwarder settings on your DNS server and point them to Umbrella, and you will be protected. If you want to do Active Directory integration and you want to get internal IP attribution information and get a little bit more granular on your policy creation and reporting, we do have a virtual appliance. It's supported on supports Hyper-V and VMware, and it will adds a little bit of complexity, but still very easy to deploy. They are not unmanaged. Once you configure those, they're hands off. We keep that updated automatically, so you don't have to look at that. So yeah, it's very, very easy.
Thank you so much, Mark. The last question I can see is, how hard is how much latency will this slow down my users' web browsing?
Well, I mentioned that in the presentation, which was we are the fastest recursive DNS provider in North America. So, I mean, we are talking milliseconds here, but milliseconds over 10,000 users can have significant impact. We're not going to add any latency, right? You're already using some sort of recursive provider or root hints, which are adding latency to those recursive lookups. Point to us, and we could likely speed up your network. And actually, there's a great white paper on Cisco, because Cisco uses Umbrella as well. We rolled this out across the entire Cisco architecture, 140,000 users in 140 different countries, and we did it in a matter of hours. And the Cisco IT department has reported better performance in many areas of the network. So zero latency, and we can probably speed up your network a little bit as well.
Thank you so much, Mark. There are no questions at the moment, but I have got a statement, or you can say a quote from Paul. He's saying, this is seriously cool stuff. Thank you, Cisco, for acquiring OpenDNS and continuing to develop it. Great level to watch and block bad stuff.
Well, thank you for that. That's great. Great feedback.
These are all the questions I have. So thank you so much, Mark and Daniel, for a great presentation. And thank you all for joining in today. If you still have any questions after the webinar, please email us at webinars@pcm.com, and I will have them answered for you from Mark and Daniel. So Daniel, Mark, have you got any last minute comments before we close?
I'm good. Thank you.
Not at all. Thank you so much for having us on.
Okay. Thank you so much all for joining us today. Have a great day ahead, and we look forward to seeing you in the future webinars. So thank you all.